Hello one and all, and welcome to my channel. And today's tutorial I am going to talk about the analysis phase and PERFORM-3D version 8 software. Okay, so make sure about the modeling phase in PERFORM-3D I have explained in previous tutorials, okay, which is part 1 and part 2. Okay, so watch the tutorials if you do not know about the modeling phase in PERFORM-3D software. Okay, both tutorial link is in the description box below. I will just open that structures which I have created in previous tutorials, okay, which was the modeling phase. I will press here, open an existing structure, okay, so I will open it, startup structure, okay, for modeling, which I have done them. It is modeling, it is overall information, okay. So afterward I'll press OK, and I have chosen here the modeling phase, okay, which all the steps and procedure I have explained in the previous two parts, okay, about it is modeling. So in this structure here in tutorial I will explain it is analysis phase. I will press here analysis and I will choose the task here as a load cases, okay. There are different tasks, okay, for it is analysis phase as well. How to define the load cases, okay. Then here is the run analysis option, and here is the run parallel analysis, okay, if you want to just start analysis simultaneously, okay, separately you will choose here the parallel analysis, okay. And if you want just import the results from another software as from ETABS or SAP 2000 or other related softwares, okay, you will choose here the import results, okay. So if you want to just learn more about how to import the results or structure from ETABS software, I have done another tutorial also, which is link is in the description box below. You can just watch it, okay. And here after analysis there is the model results, energy balance, okay, limit state groups, okay. Here this limit state group is different as it was for modeling phase, okay. And here is the reflected shapes, time histories, hysteresis loops, okay, moment and shear diagrams, pushover plots if you have done the pushover analysis, okay, or displacement pushover plots, and usage or DC ratios, okay, and it is combination and inner loops for shear force modeling, shear force, moment diagram, and others, okay, which all the tasks I will explain step by step, okay. So I will press here to set up load cases, okay, for the structure. After modeling you will do here the analysis phase, and I have chosen here the load cases. I will define here the load cases, okay. There are different load cases including gravity, static pushover analysis. If you want to just do the pushover static pushover analysis, you will do here. Or if you want to just do the nonlinear dynamic analysis, you will choose here the dynamic earthquake, which is also called time history analysis, okay, or nonlinear dynamic analysis, okay. So which is the more and the most powerful analysis type for the structure analyzation. And if you want to just do the response spectrum and upload the pushover and dynamic forces, okay, all these are the load cases, okay. I will do here the gravity, which is same for pushover and dynamic analysis, okay, and others as well. But I will do here the time history analysis for the dynamic epoch also here. It is define gravity, okay. So I will choose here start new load case. I will give a name here gravity load, okay. I will press OK, and There is analysis method. Okay, for gravity it will be linear. Okay, for others like time history or pushover, you can choose non-linear as well. I will explain in other steps. Okay, and there are the load steps. Okay, which is for non-linear. Okay, for linear I do not need to fill this information. Then I'm coming here, the load pattern. I have different load pattern. Okay, I have nodal load pattern, element, and self-weight. Okay, now I'm coming here to the load cases to define the load cases. Okay, first I'm going to define, or I have already defined here, the gravity. I'll press here the load cases type as a gravity, and afterward I will define here as a new. Okay, but I have already defined here the gravity. I will set it to gravity, and afterward I will come here to the analysis mode, whether it is linear, okay, or non-linear. Okay, gravity I will just make it as a linear. Okay, so, and there is no need for this control information for linear case. When there is non-linear, you have to put here this control information as well. Okay, so at the moment I'm using here analysis mode as a linear. Okay, so afterward I'm coming here, like I have defined here the self-weight of the structure. Okay, so then I'm coming to save it. Okay, so after defining the gravity load case, I'm going to define here the dynamic earthquake for nonlinear dynamic analysis. Okay, I am going to perform. If you want to just do the pushover analysis, you will do here the static pushover. Okay, and you will define here. And if you want to just do the response spectrum, you will do here. But at the moment I want to perform and conduct here the dynamic or nonlinear dynamic earthquake or time history analysis work. That's why I'm going to here to define the dynamic earthquake. Okay, and afterward I will just press here load case as a BAM Iran. Okay, Iran earthquake record, BAM earthquake record. Okay, so I will just press OK, and I will add the earthquake record for the structure. Okay, I will specify it is location. Okay, it is BAM Iran earthquake record. Okay, so let me just open it. Okay, this is the record for Iran. Okay, I will open it, that record. Okay, so the lines to be skipped is 4. Okay, 1 2 3 4. Okay, so and the number of acceleration per line is 5. Okay, 1 2 3 4 5 lines. Okay, and here the time interval is 0.005 seconds. Okay, I will just copy it. Okay, and I will paste it here, and the duration is 10 seconds. Okay, and acceleration unit is g unit. Okay, so I will name it here earthquake. Okay, so afterward I will file name here, and I will check it. This is the earthquake record. Okay, I will press OK. The earthquake record has been added successfully. I will just return back. Okay, this is the Iran earthquake record. Okay, the total time in seconds will be 100. Okay, and the time step is 0.005 seconds. Okay, and here the maximum event, okay, will be found from here, 8448. Okay, I will just paste it here, and the limit set will be drift. Okay, h1, and here also h1. Okay, I will just press OK, and I will go here to the next level as a series. Okay, analysis series. Okay, so I will define here the new structure. Okay, the time history analysis, okay, and nonlinear dynamic analysis, okay. So I will put here that equity code, okay, and I will come here the basic parameter will be standard for load sequence, okay, and I will consider the p delta effects for the geometric nonlinearity of the structure, okay, in the event will be 5, okay. The 50 modes will be considered and the mass will be 1, okay, as a scale, okay, and I will come here. The damping ratio will be 2.4%, okay, and relay damping it will be 0.2 and 1.2, and damping will be 0.1 and 0.1. Afterward, I will just press OK. Look here. I will define here the gravity to be added, and also the dynamic equity code will be added here as a band, okay, and this one added here. I will just delete this one, okay, and also gravity and the equity code. Afterward, I will just press go. If you want to just don't go, all the results will be saved separately, and we will just going to define another records, okay, or load cases, okay, and I wanna go here to press go. Okay, the analysis is in progress. After a while we will see its results, okay. It may take some time, so afterward we will see its result, and I will show you other steps as well. So means for this earthquake record there are like 20,000 steps exist, okay, so it will take more time because to reach to 20,000 steps, okay. So if there is like moderate earthquake or very low earthquake, so there will be no need to take that much steps, okay. Okay, the analysis were completed successfully, okay. I will just press OK and continue, okay. So look here, it is detailed information, okay. The gravity load and earthquake record has been applied here. Look here, it is status. If you want to just see it is details, you will just press here, okay. So afterward, okay, after completing the analysis, I will go here to it is results, okay. So if you want to just import some results, you will just press here this button, okay. So I'm going here to the model analysis results, okay. Look here, if you want to just see it is mode shapes, okay, you will just put here like we have inserted there about having 50 mode shapes. Like look here, it is mode shape 5, okay. Look here 8, okay, and also 14, okay. Like this one, like it had different mode shapes, okay. Look here 3. So if you want to just animate the mode shape, you will just press animate the mode shape. Look here, it is just showing it is mode shape. So if you want to just do here, look, animate, so like it is just animation, okay. So like drift also, this is about each one in each two directions, okay. So like if you want to just show the results about so all the, if you want to, you can just save it or show the mode shape as well, okay. Here, sorry, the drift, okay, and other information here. Now I'm coming here to the energy balance. Okay, you can just plot it here. If you want to just show, look here, you will choose here it is series. Okay, and it is case. Okay, you can draw here for some elements as well. Okay, and this is the limit state. So for analysis, okay, the previous limit state here, it was for modeling phase, and here it is for the analysis phase. Like if you want to just do some limit state here, you can just do. So for example, I will just put here as a deformation. Okay, so the deformation I will do here for beams. Okay, immediate occupancy, add. Okay, also again here for limit state. Okay, I will add. Okay, and for collapse prevention, add. Okay, and save it. Okay, this is for beams, and you can just do for column as well, or you can just do for another cases as well. Okay, this is just the information hint I just have explained. Now I'm coming here to this portion. Okay, so this is the deflected shape. Okay, look here, like, so you will choose here the simple scaling or base structures. Okay, and afterward you can just do it is plot. Okay, so it will animate by progressing the time, so you will see it is plot as well. Okay, if you want to just see about the limit state, okay, all the information, or you can just choose from the group. Okay, so and here it is the ratio about like where the structure has been collapsed or fell. Okay, this is also regarding the plot option here. Okay, so if you have different earthquake records, okay, you will choose from here different earthquake record results. Okay, and here this is the time histories. You can see here, like if I want to just see for relative displacement. Okay, so I will select here the relative displacement, and I will choose it is unit as a meter. Okay, and I will just select here as a node, and afterward I will plot it. I'll just come here, like I will select the maximum point. Okay, I will select this point, save it. So it is result, the results of relative displacement about save maximum and minimum only. After saving, you will specify its location here, browse, you will choose its location. Okay, and you will give a name here and save the results. Okay, so it is all the results can be saved like this. Okay, so after I'm coming here to the hysteresis loop. Okay, this is basically for pushover analysis. Okay, so if you want to just group some elements, okay, you can just do from here. Okay, so look here, I have selected this column, this is the choose column, and you can just do this plot. Okay, so this is moment and share diagram for each and every element. Okay, for example, for beam group or column group. Okay, you will choose here, and you just gonna do it is moment and share diagram. Okay, it with time hysteresis loops and others in deflected shape as well. Okay, so I do not want to go here for details. Okay, I will do all the details for analysis in another tutorial. Okay, for the next tutorial. So if you are interested to do to see and understand about all the results of PERFORM-3D, so do not forget to watch the next tutorial. Okay, so this is the pushover plot. Okay, so if you wanna just do the pushover analysis, all the results will be achieved here, but I did not done the pushover analysis at the moment. I have performed the time history analysis. Okay, so you will just go here for the pushover block here. and all the information about base shear and other accelerations will be found here, the deformation, drifts and others. Okay, but I did not done here the pushover analysis. Okay, so the next tutorial I will also do the pushover analysis for the structure. Okay, so this is also about the pushover steps, okay, or the target displacement plots. Okay, so like look here, the load cases is like not available if I have performed, or if you want to just do the pushover analysis, all the cases will be exist here. And this is the DC ratio graphs here. So all the DC ratios graphs about the deformations or the groups which you have defined or the drifts will be shown here. Okay, and this is the combinations and envelopes about the structure. Okay, so like if you have some combination and you want to see it is combination about it is results, the maximum, minimum, or the medium results, okay, or average results, you will choose here, and you will choose it is limit states from here group, and you will just plot and see the results. Okay, so I have just roughly explained this information about the results sections. Okay, but on details I will explain all the results in coming tutorial. Okay, so it was the third lecture about the PERFORM-3D and how to understand about it is analysis phase. Okay, so if you want to just look and see and understand about it is analysis results and the analysis phase, do not forget to watch the next tutorial. Okay, so in that tutorial I will explain some portion of modeling phase and on detailed information about the analysis phase of the PERFORM-3D version 8 software. Okay, thank you so much for your attention, and do not forget to subscribe this channel. Have a wonderful time.